Hello everyone, my name is Maxime Chagnot. I'm a CATIA consultant working for PLM technology in Norway, and today we'll show you a video about power copies and cutouts. So power copy is a really great tool in CATIA since it allows you to regroup a certain amount of feature in only one in order to make it a template and later transform the repetitive task in an easier way. So today in that video I will show you how we can make a curved plate, a double curved plate that could be a sheet metal part for example, and we will do cutout on the side of this plate. It could be easier to use a pattern, but in that case a pattern will be more flat, so that's why I make a double curve plate. Okay, let's start by making a 3D part. I will call it metal curved plate. Okay, and before going to sheet metal, I will start by making the shape in Generative Shape Design, that is the shape application in CATIA. So I will work with geometrical set, and you will see in my video that I will make several geometrical sets in order to see the different steps of my design. And this is up to you, but I prefer to work that way. It's a bit easier for me to understand, and it could be also easier for the colleague to understand as well. So I will start by making original shape, and you will see here we'll make a double curved surface. So we will just make two curved. Okay, it does not really matter the shape it is, just want to show you. I will make it a bit less curved to be a bit more real. Okay, and I will add another one perpendicular to this one. You see, we can even change a bit the orientation. That should be okay. It's going to be pretty well curved. You will see when I click on sweep, since I will do a sweep of these two curves, sorry. So that's the double curve plate we have, and now I will do a cutout here because I want to have something a bit more curvy than just 4 edges patch. Okay, I will just open my geometrical set and hide these two sketches because I don't need them anymore, but they are still here, so it's just hidden. Now I will go on the plane here and I will make the cutout I want. So you see I use the curve feature and I just make a lot of points, and instead of clicking here to close the spline, you right click on the mouse and you select close spline, and now you have a fully curved profile. So it's a bit like a potato shape, but it's perfect for the case we want. I exit that and you see that the sketch is not lying on the surface, and that's normal, we made it on that plane. In order to put it straight to the surface, we need to use the feature projection. So I will project this sketch to my surface, but I will use the option along a direction, and I want to project it along set. In that case, I'm sure it's perfectly lying on the surface, and I will also remove nearest solution. I prefer to keep it that way, and now I can hide the original sketch, and you can see here we have a curve on the surface. Now I will split my surface with this project curve. Okay, and now we have the final plate. Great, now let's move to the second part. Here I will create axis system or point here, and that will be the original area for my cutout, and later we will do several cutouts on the edge. So I will just call it original cutout. Okay, so as you can see now it's underlined, so I'm working on that geometrical set. I will also hide this project here, that is the boundary of the patch here. Okay, and now I could, well, let's first create a parallel curve because I don't want my cutout to be on the edge. I want to be a bit before. So let's put 10 millimeter. So what I do here is I select the option parallel curve and I select the boundary of my patch here and I put 10 millimeter, and you see it's on the support here. So meaning it's lying on the surface, and that's a good thing. You can of course modify this value. You can put 15, 20, etc. Of course, if you put too high, it will be you will have a problem at the center here. Okay, and now I want to make a point. But if I select the point option on this curve, the software will just bring me a point in the curve. And like if you see, if I put 0, it's going to be this one. It's not really what I want. I want to have a point maybe in that area. So I will use intersection. I will intersect this plane with this curve here. And as you can see, you will have two results. You will have a point here and a point here. So when I click on OK, the software will say that you will have two results, and you would like to select the option keep only one sub-element using extract. When I click on OK, you have the extract feature that appears, and you will select this one there. Okay, the software find it, click on OK, and now you have an extract. Okay, next step, we are going to make an axis system on that point lying to the surface. But before creating that, I will make a plane tangent to this surface passing through this point. And as you can see, the software automatically finds it. I click on OK, and I will also make two lines. The first one is going to be tangent to curve. Okay, so this curve passing through this point, and you see 20 millimeter in that way. Great, you see it's lying here. And I will make another one, and this one is a bit more complex. It's angle normal to curve. So basically what I want to do here is I want to select this curve passing through this, well, the support is going to be the plane. It's say, okay, and the point here. And now I don't want 45 degrees, but I want 90 degrees, preview, and except that you want it in the other direction, so I select reverse direction there. Okay, so if you don't really see them, properties, I can put some color here. Okay, pink, and of course you can put it a bit more thick, but it's just for you to see. So you see, basically, I've made an axis system manually, okay? But it's just for the axis system feature here to find it easier. So now I click on axis system, and you are going to say that you want to have an axis system on this origin there, okay? And the X could be this one, and the Y could be this one, okay? And now you can play with reverse feature if you want, but in that case it does not really matter, because the software understands that's what you want. Okay, so at least, okay, we can make it that way. Great. Now I click on OK, and you can see that I have an axis system here. I will just hide these two lines since we don't need it anymore. Actually, I'm going to just hide the cutout. No, wait, I need just to hide these two here. Yeah. Yes, and I also hide this plane. We still want the extract there. Okay, now next step. We are going to make several of this axis system on the curve. So I go to Wireframe, and I can even create another geometrical set where we'll call it repetition. Okay, so now you see it's underlined. I'm working on that geometrical set, and I will select the option points and plane repetition. What does it ask you? The first point is my extract. Then the curve is this one, okay, and then ask you the instances. Let's start with 10. Okay, and very important here, you can select create axis system, and of course you select this one as the axis system you want. and you select the option along surface. Yes, here it is. And now they are lying, all the axis system are lying on the surface you created. I think it's pretty consistent here. We see all the Y are down. Well, it does not really matter because the only thing we want is just to have this line here. Okay, now we click on OK. So as you can see, we have 10 axis system. That's great. You can find all of them there. And now we will do the step of the cutout. So I will make a power copy in that case. Okay, we can already save this and we will come back to it later. Okay, I create a new part that I will call master power copy cutout. Click on OK. And now we'll make the power copy. So that's the second step of the video. Still in Generative Shape Design, I will make a geometrical set. I can even call it cutouts. And now we make the power copy. And very important in the power copy, you should not reuse this tree plane. You should make your own plane with your own axis system. So what we will do, I make a plane based on this one, but it does not really matter. I put 0 millimeter. I will hide this tree plane now. Okay, so you see there is only this one, plane 1. Now I will make a point. We know that this point should be 0, 0, 0, 0. Okay, and I will make a line. So you want to make this, I think it's going to be point direction. Okay, so you want to have this point here, and direction is not going to be this one because this one is going to be normal. So we'll just select this one. Okay, or if you prefer, this one. Okay, reverse direction. Okay, so now we know that we have a plane, a point, and a line, and that's what we will need later for our power copy. Let's make a sketch now based on this plane here, and we are going to make the shape of our cutout. But be careful, you don't want to use U, H or V. So, for example, if you make a line here, you don't want to have a V here. You don't want to be, or in that case it's vertical, but you see it's because I should have made my line in that direction. So if you want to get rid of that, we can delete that. I delete the sketch, and now my line here, I will not select this one, but I will select this one. Okay, well, it does not really change that much. I go back to my sketch here, okay, and what I said is this line, you don't want to be horizontal here. I click on delete, so meaning that it can be that direction. That's not good. You are going to make a constraint manually here. So you will select this line and this line here, and you will put 90 degrees. Also, you will select this line and the point we created here to make a coincidence. And now it's a bit up to you to decide the shape you want. Let's make something rather complex, but everything needs to be constrained. So let's make maybe an arc. Okay, so that could be the shape, huh? So you say you want the radius and you want this point to be connected to this line there, coincidence. And we could also make something a bit more complex, maybe to show the real advantage of that tool. Let me see. Okay, so what I'm going here is I will trim that here. Okay, so that could be the shape we have. So this one is 8 millimeter, this one is 10, for example. And I will now... So it takes a bit more time to do it since you don't use the horizontal tool, but you will understand. So that could be the shape of our cutout. Very important, you need to constraint everything. So what do we need here? We need an angle there. Okay, 45 degrees, for example. We have the radius here. Okay, so what we need now is that this center here, the center of our arc, is coincident to that line. And now it's fully constrained. Am I right? Ah, another thing, you need that this line and this line here, I will put it as a constraint element, are passing through the center of the radius, and I will select tangency. Okay, great. So now we have the cutout we want to do for our plate. I exit. It's a bit complex, okay? And I will now make an extrude. And I will say post direction, mirror extended, 20 is a bit too big, so 10 millimeters should be enough. Okay, so that's the shape of our cutout. And you can also hide the sketch because we will reuse it in our design, so we don't want to have the sketch always shown. Okay, now what do we do for the pour copy? You will go to Tools and the tab, and you click on Pour Copy. You see the panel is here, and you select Extrude, that's the feature we want, and here it says, if you select the extrude, you will need a sketch as an input, but we don't want to make the sketch, obviously, so we select the sketch as well, and now it says, you will need a plane, a line, and a point, and that's what we want. You can also rename it Pour Copy, Cutout. If you want later, you can also add some parameters in that Pour Copy. You can see you could add, for example, the radius, 8 and 10. Well, in that case, it's not very important. I will not change it in the video, but that could be possible. Okay, I click on okay, and now it creates this pour copy here. The pour copy is only in this part, so you will have to save this one. But if you want to find it later in the 3DExperience, you can also select save in the. You can also save it in the catalog. Okay, now we go back to the metal curve plate. Okay, and we are in repetition now, and I will instantiate my pour copy. How to do that? You will still be in Tool, and this time you select Instantiate from Selection, and you go to the master pour copy, and you select it. Now we are back to the part, and we have this panel that appears here, and it says that we need to select a plane, a line, and a point to create this pour copy, and this is what we have. So another thing is pretty nice is you have this small repeat function here that allows you to do it several times in a row. Okay, let's start by the original one. As you can see, this one is maybe not easy to see, but this one are dashed. Okay, we select the plane. So the plane is this one here. Now you select the line. The line should be this one here, and the point is the tiny point here. Click on preview, and if it's not the direction you want, you can click on the line here and select that. And now you have it on the other side. Click on OK, and this is a bit still repetitive, but you can it really change it. It's really fast to do it. So I select the other plane, the line. Now I know it's in the other direction, and I select the point. Click on OK, and I continue that way. Okay. And we have done all of them now. So I click on cancel, and now I'm stopping here. So we have done the cutout now with the power copy. Let's create a sheet metal part. So now I go to the part body here, and I switch to sheet metal. And the first thing you need to do in sheet metal is to set up the parameters of your plate. And here is going to be a thickness of 2 mm with a bend radius of 4. I click on OK. And if I go straight from this feature, freeform to surface, you will see we'll have some issue because it will need to have a line to tear to make the plate flat. So let me show you here. I select this feature, freeform to surface, select the surface, okay. Select a reference wire. We don't have any, so we'll have to make one. So I've been a bit too fast. I create another geometrical set. Line, okay, and I switch to Generative Shape Design. If it's too much for you to see, I will just hide this, okay. What do I want to do? This line, I'm going to make an intersection of this surface and this plane. Okay, great. It's perfect for me. And now it will also ask a point, so we can even say 0 here, ratio 0. And there you have the point. Okay, so now I switch back to sheet metal, application, great, and I can select my freeform surface. The surface is this one, the reference wire is this one, and the fixed point is this one. Preview. It makes a bit of time, sure, but now, as you can see, now it's becoming a solid, okay? And you even have some option if you want to have it on top or on the neutral. Let's say neutral is a bit better. Here, as you can see, it's passing in the middle. Okay, we can hide this line, we don't need it anymore. And good thing, if I click on unfold, now you can see that's the plate, so you can make a drawing directly because now it's flat. Okay, I will show again. So we don't need the original shape, but we can have the cutout, the repetition there. So what do we need to do now? We can select the refine feature, the refine tab. You select the option cutout, and when you click double time, it will select in a row. So let's start by the first one. The first one is this one, and be careful because if I click on preview now, it will remove the outside. So you need to change the arrow in the inside of the cutout. You click on OK, and we do the same with the other. And here I'm done. Okay, so I can even hide this, and I can also hide this one. Okay, and if I click on unfold, as you can see here, we have all the cutouts we want on this flat surface. You can even make a drawing directly, and if you want, send it to a machine that can punch all this hole. Of course, in that case, it was half, how to say, it's still a bit manual, but there is still some robustness in that assembly, because now if I modify, you will see if I modify the number of repetition, some of it will follow. Let me explain. If I put, now if we say that we want 12 preview, it will work in that case. Okay, so what does it do here? It's maybe not easy for you to see because all of them are hidden now, but we still have the 10 cutout we do, and now we have 2 extra. So if you want to make 2 more, we go back to the power copy, and we select this one there. I select my power copy, and we can add 2 extra. So I will select member, the plane, the point, the line, and the point, and click on repeat. Okay. I know what I've done. I think, yeah, my mistake was that I was not working in the repetition geometrical set. I was working on line. No problem with that. What you can do is just select this one, extrude, and change geometrical set. You put it into repetition, last position, okay, and same for this one. Change geometrical set and repetition. Last position. Okay. Actually, this one I can delete since it's in the other direction. I will instantiate it again. So I want to be sure I'm working on repetition, defining work object. Okay, and now I will search it, power copy, and plane, line, change the direction, and point. Okay, here it is. Okay, so we have added them manually, but we can just go back to our sheet metal. So you see the sketch are here. Well, it's not a big issue there. I will use the cutout feature in refine. I will show this, and I will do a cutout of this one and a cutout of this one. Okay, and now again, what if we go back to what we have done? So here we basically did reuse the feature to do 2 more holes, but what if we remove to 8 holes, for example? It will work, but then it will say that you have 4 extra cutouts. So I put 8, yes. Okay, it said that you have an issue, it's no problem. And we are going to update. And here it said that this one you want to delete. So here they say this one you want to delete. So I will hide. Okay. And this one delete. Okay, and the 2 last one we created, delete as well, and delete. Okay, and now we are good, except that the sketch, we don't need it anymore, and this sketch as well. Okay, and now, oops, I will just hide this one there. Here it is, and I can still unflat it. So here, this video was to show you that Power Copy is a great tool in a way that when you have this complex task to do, it can be really nice to use it to make your own feature, more or less. And you can just select several inputs. So there is a bit of manual work in that, but there is still some robustness in it, since you can very simply click and place the cutout you have. As you can see in my other video on YouTube, I have done several example of that Power Copy. I did it with a tube, and I did it with a profile according to a line. In that case here, it's a combination of a sketch and a generative shape feature, but as you can see here, I could use that power copy in sheet metal directly. And the good thing here is I know that my shape, my cutout here is perfectly perpendicular to my shape, and when I unflat the model, it will follow. If you have, for example, a punching machine that have this this tool here, it will follow all the curve. And okay, it took 30 minutes, well, a bit less than that. Actually, it took 20 minutes to do the plate with the number of hole. So it shows you that it's kind of fast to use it. And also another good thing is every time you will have to do this kind of cutout here, now you have it saved in the 3DExperience since it's a power copy, meaning that I have a customer that does it a lot. He has this cutout in all these plates, and he can just reuse it every time, and everyone in the company can reuse it. So it's a very time saver in CATIA 3DExperience. Well, that was it for me today. So thank you very much for watching this video. I just want to say a big thanks to all the subscribers. If you want to see more, please visit our YouTube channel and also our website www.plmtechnology.com, and I hope to see you again very soon. Thank you very much. Goodbye.